Slides are visible.
Okay, so I'm going to talk on the solar system, which is a very important topic for all the teachers who are attending this session. And I will give you a brief overview of the whole solar system, and subsequently I will also talk briefly about what India has done in the exploration of the solar system. Before I go into detail, let me tell you that I am from Physical Research Laboratory in Ahmedabad, and this is the institute which is one of the oldest in the country, established in the year 1947 by the father of Indian space program, Dr. Vikram Sarabhai. And it is called as the cradle of space science in India because all space research and space technology program started from PRL, that is Physical Research Laboratory. Here I hope you may be able to see Dr. Sarabhai. I hope you can see my cursor. Somebody can confirm. Are you able to see my cursor? Move me?
Yes, sir. Yes, sir.
Okay, good. Thank you. And the gentleman over here who is showing Dr. Sarabhai, this rocket, is none other than Dr. APJ Abdul Kalam, the former president of India. And on the back, you are able to see Dr. Madhavan Nair, who was later on the chairman of ISRO, Secretary Department of Space. So all the space research activities started from PRL, whether it is rocketry program, satellite program, ballooning programs, and things like that. And the first rocket launch, which happened from Thumba, that is in Trivandrum in Kerala, on 21st of November 1963, actually carried experiments developed in PRL. So PRL was actually developing the experiments. Dr. Kalam was sent to Thumba to develop the rocketry program, and Dr. or Professor U.R. Rao was actually sent to Bangalore from PRL, where he was the professor, to develop the satellite program. So this is just to give you a flavor of how PRL all started. It all started in a small building over here in 1947, moved to MG Science College, and then this is the first council meeting of PRL happening with the gentleman standing over the mic is none other than SS Bhatnagar. And if you look at how the development of the whole building of PRL started, it is in 1952 when the PRL campus foundation was laid by none other than C.V. Raman, the Nobel laureate of India, because Dr. Sarabhai used to treat Dr. Raman as his actual guru. And this building was inaugurated in 1954 by then Prime Minister of India, Pandit Nehru. And you see the building on the top right, and then you see in 70s the building back. You are seeing a multi-story building, 8-floor building, and this is how it looks a couple of years back on 15th of August. We have 2 more campuses of PRL, which one of them is in Mount Abu, which houses the infrared telescope, and other one is in Udaipur, which houses the Udaipur Solar Observatory. So in Udaipur, we have an observatory which looks at the sun, but in Mount Abu, we have an observatory which looks at the sky in the night. And this Mount Abu observatory is now further refurbished. We have another new telescope which has come up in Mount Abu, which is a 2.5 meter telescope, and previously we had a 1.2 meter telescope. Now talking about the PRL in further details. So PRL now has completed 75 years of its existence. So as we celebrate Azadi Ka Amrit Mahotsav, that is the 75 years of independence of India, we in PRL are celebrating Platinum Jubilee of PRL, and therefore we started a very special Vyakhyan series in PRL on 4th of August 2021, that is about 2.5 years back, when we took a sankalp that we will organize one Vyakhyan every Wednesday at 4 p.m. And we had a series of 75 Vyakhyans occurring every Wednesday at 4 p.m. And it got completed on 5th of January 2023. If you are interested to look at these Vyakhyans, you can note down this PRL YouTube channel, or you can search in Google the PRL plus YouTube, and you will be able to see all the Vyakhyanas which are kept on the PRL's YouTube channel. Dr. Sarabhai has a crater on the moon in his name called Sarabhai crater, and that is on the near side of the Earth. So you can see this crater with a small telescope. It is at 24.7 degree north and 21 degree east, and it is fairly big. It is about 8 kilometer in diameter and about 1.7 kilometer deep. And this picture you are seeing is from our own Chandrayaan 2 instrument called Terrain Mapping Camera, or TMC2. We very recently discovered a crater on Mars. And this crater, based on the suggestion from PRL, is now named as Ramanathan crater. Ramanathan was the first director of PRL. And in his honor, International Astronomical Union has named this crater as Ramanathan crater. Now, talking about this logo, which you must be seeing in some of my slides so far, and you are seeing a big circle with two circles in the center. So how do you interpret this? What does this logo mean? Actually, if you look at a logo or the circle with a dot in the center, right, on the left side, it looks like an eye. This is nothing but the symbol of the sun. And on the right side, you have a circle with a cross in the center. This is the symbol of the earth. Now, these two circles are joined with two lines, and then you have another big circle encircling these two small circles. So how do you interpret this logo? It means PRL research encompasses the earth, the sun, immersed in the fields and radiations reaching from and to infinity, all that man's curiosity and intellect can reveal. So essentially the research in PRL encompasses everything from the core of the earth to the end of the universe. And therefore, if you look at the research activities of PRL, it encompasses astronomy, astrophysics, solar physics, space science, planetary science, earth science, geoscience, atomic molecular physics, optical physics, and theoretical physics, as well as planetary sciences. So if you are seeing this slide in the bottom, you are seeing the 4 campuses, which I just discussed. And in Ahmedabad itself, we have 2 campuses. One is the main campus, which is in Navrangpura, and the other one is the Thaltej campus in Ahmedabad. And if you want to get a little more details about PRL history, you can see some of those photographs of the alumni or the students of PRL who did their PhD from PRL, including Professor U.R. Rao, who did his PhD under Dr. Sarabhai, Dr. Kasui Rangan, who was a student here, and you know very well who he is. Dr. Kalam was working here in PRL. And then there are many others which are shown over here. They are all who did their PhD in PRL. So let us go to this, our main topic of today's discussion, and which is the solar system. So when you look at this picture, you will see that we have sun on the left, and then there are 4 inner planets: Mercury, Venus, Earth, and Mars. And then there are 4 outer planets: Jupiter, Saturn, Uranus, and Neptune. And there is a small planet called Pluto, which is in the outer part of the solar system. So this shows that the inner part of a solar system consists of very small planets, whereas the outer part of a solar system actually consists of big planets, which are called as giant planets. They are also called as icy planets or gaseous planets, whereas the inner 4 planets are called as rocky planets or terrestrial planets. And the simple way to remember the order of these planets is my very excellent mother just send us 9 pizzas. That means the first letter refers to the name of the planet, like Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and Pluto. But you also know that very recently, about more than a decade back, Pluto is not considered as a classical planet. And hence, this rhyme has to change now. So what this rhyme will be, it will be my very excellent mother just sent us noodles. So instead of 9 pizzas, it has become noodles because it ends at Neptune. So what is a planet, or what we call as planetary science or planetary astronomy or planetology? So why Pluto is not considered as a classical planet? So that means we now have a definition of a planet, and a planet is a body which goes around the sun. Of course, Pluto also goes around the sun. But then it should be sufficiently big, or sufficient mass should be there to have a self-gravity which overcomes the rigid body forces and assumed a round shape. Of course, Pluto is round in addition to other planets, right? But then the third definition is that a planet has to clear its neighborhood. That means there should not be any body around or in the vicinity or in the neighborhood of that planet itself. And this third definition is not fulfilled by Pluto because there is a satellite of Pluto called Charon, and I will show you that later on. And hence, because of this, Pluto is now considered as dwarf planet. So now when we consider our terrestrial planet, the 4 inner planets, that is Mercury, Venus, Earth and Mars, we say that Earth and Venus are roughly same in size. Mars is about half the size of the Earth, Mercury about 1/3. But when we go to the outer part of the solar system and compare this to the inner part, we say that Jupiter is the biggest, second is Saturn, then comes Uranus, and then comes Neptune. So the Earth is 5th largest planet in our solar system. And when you compare this with respect to Sun, now you will see that Earth is a very small dot. Jupiter itself is quite small compared to Sun. And against this small dot, which you're seeing on this screen, now you can imagine where you are, right? So we are very, very small in size compared to the size of the planets. And our own Earth is much smaller than the size of the Sun. Now let us look at the new solar system. And you are able to see now these 4 inner planets, the 4 outer planets, and a new category which we call as dwarf planet or minor planets, and Pluto is considered in that. In addition to Pluto, now we have few more planets which have been discovered beyond the orbit of Pluto, which we call as Huma, Makemake, Ares. And then we have other bodies in our solar system like asteroids or comets, which are very, very interesting objects, and they also make us understand how our solar system has evolved or formed from the beginning. Now looking at this, you will see that the inner part of solar system where we have very small planets, we have Earth which has a moon or a satellite, a natural satellite. Venus doesn't have any, Mercury doesn't have, Mars has 2 very small satellites. But when you go to the outer part of solar system and you talk about Jupiter, it has very big satellites, very large number of satellites, more than 50. Now it is topping around 70 or 80. Saturn has already crossed century. It has more than 100 satellites. And Uranus, Neptune also has big satellites. So outer part of solar system is much more rich, being bigger, that it has very large number of satellites. Now let us look at these objects. And if you look at trans-Neptunian objects or objects beyond the orbit of Pluto, and you say Ares, Makemake, Huma, which I was talking about, Pluto has a satellite called Charon, which you are seeing over here now. And this is roughly the half the size of the Charon, or you can say 1/3 the size of the Pluto itself. And then you have Sedan, Quair, Varna, or Orcus, and these are all in the orbit beyond the orbit of Pluto. Now I was talking about the asteroids, and Cirrus is one of the largest asteroid in the asteroid belt, which is a belt between the orbit of Mars and Jupiter. And you are seeing these small dots in the circle beyond the orbit of Mars and between the orbit of Mars and Jupiter, where you see very large number of asteroids. And the biggest one is of course Cirrus, which is containing almost like 1/3 the whole mass of this asteroid belt, and it is almost like 1,000 kilometers in diameter. Similarly, if you look at these small asteroids like Ida, which is shown over here, which looks like a size like a potato, right? And its surface, if you see, it is having craters. So a small body of some 30-40 kilometers in size itself has a small craters, and it also has its own moon, which is called Dactyl, which is hardly a kilometer in diameter. So that means there are objects in our solar system which are very small, but they are also cratered bodies, and they also have their own natural satellites. Or you can see this where you see various forms of different asteroids in different shapes. Eros is the second largest near-Earth asteroid. Near-Earth asteroid are asteroids which are closer to the orbit of the Earth, and that's why they are called as near-Earth asteroid. And even here, you can see on the surface there are craters. Comets, which I was just mentioning about to you, are also very interesting objects. They are quite small in size. The nucleus can be hardly a kilometer to a few tens of kilometers in size, but they develop a very long tail when they come close to the sun. Because of the heat from the sun, the nucleus, which is largely made up of volatiles and mostly water vapor or H2O, starts sublimating. That means it goes from the solid phase to the vapor phase straight away. That's called sublimation, right? And because of this sublimation activity, it develops a long tail, which can be even million kilometers long. And that's why we are able to see the comets by not looking at their nucleus, but looking at the coma or the atmosphere and a long tail. And comets are believed to be one of the processes by which Earth has got its water. So that's why comets can be called as a messenger of life. They are also important from cosmological and cosmogonical point of view. And the size of the comet, which I was just mentioning, can be, you see here the comet Holmes, and this is the hydrogen coma of the comet, can be even larger than the size of the sun itself. Now, what I'm going to do here is I will show you a small picture which shows a park. In the center there is a small road which is going through this park, and you're seeing a tree and the grasses. And I'm going to zoom this picture by a factor of 100, and you will see how we can actually get a feel of the dimensions or the length. If I zoom it by a factor of 100, the distance comes from 52 feet to almost like 1.6 kilometers. And you are able to see these different roads in a city, some flyovers and crisscross roads going around, some stadium and things like that, right? And the red arrow which you're seeing over here is actually the place which I've zoomed in, okay? If I zoom it further by a factor of 100, I'm able to see a big state. And I can also see these rivers, which are shown as black lines across this big terrain, right? This is a infrared picture. And if I zoom this further, I see the dimensions of the Earth. So from this picture of a person or a lady sitting on a bench in a park, by 3 steps of 100, I am able to go to the dimensions of the Earth. And Earth's diameter, you know very well, right? Its radius is 6,400 kilometers, right? Now, if I'm zooming it further, what I see? I see the Earth and the Moon system, right? And if I go it further, I go to Sun-Earth distances like 1 AU. So what I've done, I have changed from feet to kilometers, and finally coming down to almost like 1.6 or 160 million kilometers. And this is called 1 AU. That is the mean distance between Sun and Earth. So just 5 steps from this picture in the top left, I have come to the dimensions of the Sun and Earth. And now I go beyond, then what happens? I take another step of 100. And now this dimension which I'm seeing here is represented in astronomical unit, 1.1 astronomical unit. I go a factor of 100. I have crossed the whole solar system. I have crossed beyond the orbit of Pluto. And if I go further, what happens? I see only the sun of the solar system and nothing nearby. That means there are no stars within 11,000 astronomical unit of the sun. Moving further, I could now see, when I zoom it by a factor of 100, some stars, right? And the dimensions have become again big. You can say it is 1100,000 astronomical unit. So I convert this into a still bigger unit, which is called light year. That means the distance the light takes, or distance the light covers in 1 year. And this is 17 light years. Zooming it further, now you can see many stars, right? And the center is our own solar system. And still beyond, I can see the whole galaxy, our own galaxy called Milky Way galaxy, right? And our solar system is on one of the arms of this Milky Way galaxy. So now I have come to Milky Way galaxy from that picture which I showed you in the beginning, which is showing only a small park. What happens if I zoom it further? If I zoom it further, I see our own galaxy and I see some other galaxies nearby. Okay. And if I zoom it further, I see this picture. That means I have already crossed the dimensions of the universe. How big is the universe? It's about 14 billion years. So what I have done, from a small step of hundreds and multiplying it from the dimensions of something like a feet or a few tens of feet, I have crossed to the dimension of the universe. So you have to get a feel of the dimensions of the length by looking at the objects and then try to gauge the distances. Now let us come back to this picture, which shows our own sun in the center. We are seeing the orbit of the Mars, Earth, Jupiter, and of course Uranus, Neptune. And let us look at the planet Earth. Now you are able to see this Earth, where we know that Earth is tilted, and it is tilted by 23.5 degrees. So that means the Earth is not straight like this. Earth is tilted by 20.5 degrees, and this is how it goes around the sun. And because of this tilt, we have seasons, and we have 4 seasons largely, right? Summer, winter, autumn, and spring. Now, if you look at the tilts of the other planet in our solar system, and you look at the tilt of the Earth with respect to them, you will see that Mercury has no tilt. Mars and Saturn has tilt which is very similar to that of the Earth, around 26 degree, 27 degree, 25 degrees. Jupiter roughly vertical, straight, 3 degree. But look at a planet Uranus, 98 degree tilt. That means its pole is looking towards the sun, right? Or Pluto, for example, which is a 120 degree tilt. But now the planet like Venus, it is 177 degree. That means what? It is rotating retrograde. It is not rotating like all other planets in our solar system. It is rotating ulta, retrograde. Okay. The masses of the different planets, and here you know, because Jupiter is the biggest planet in our solar system, it is the most massive. Then comes Saturn, then comes Uranus and Neptune, and Earth is the 5th largest and the 5th massivest planet in our solar system. If you look at the length of the day, on Earth, we say it is 24 hours, right? So Earth takes 24 hours to spin on its axis. That's called the length of the day. Now, if you look at Mars, it is slightly more. It is 24 and a half kind of thing, hours. But If you go to a planet like Venus, it has the longest day. It is 243 Earth day. That means it will have something like 122 days long day and roughly equal long night. And if you go to a planet like Jupiter, it just takes 9.8 Earth hours, less than 10 hours. So that means a Jupiter, which is so big, so massive, is spinning on its axis very fast. In 10 hours, it completes its one rotation. Whereas Venus, it takes 243 Earth day, right? So that means the slowest spinning planet in our solar system is Venus, and the fastest spinning planet in our solar system is Jupiter. Let us look at the density of the planets, which is also very important for us to understand, the formation of the solar system. And if you look at here, you find that Earth is the densest planet. So here, Earth is coming at number 1, and it is density of almost like 5.5 gram per cc. And if you look at the density of Saturn, it is the lightest. It is lower than the density of water, which is 1. So that means Saturn will actually float if you put it on the water. And if you compare these inner planets, that is Mercury, Venus, Earth, and Mars, they are always denser planets. So that means the inner part of our solar system is small, but they are dense planets. Whereas the outer part of our solar system is big, but they are lighter planets. Now let us look also at the magnetic field. And we know very well that magnetic field is also a very, very important aspect of any planet. We have planets in our solar system like Earth, that is Jupiter, Saturn, Uranus, and Neptune. They all have intrinsic magnetic field like Earth. Whereas Mercury or Venus or Mars does not have any strong magnetic field like Earth. Now, this magnetic field also has its own axis. And there's always an inclination between the spin axis and the magnetic axis. And if you compare this and look at Earth, it is 11 degree between the magnetic axis and the what you call spin axis. In the case of Jupiter, it is about 10 degree. Saturn, both are aligned. That is the magnetic axis and rotation axis. But Uranus, if you look, it is tilted by 60 degrees. Uranus, you remember, was pole on, right? It was looking towards, the pole is looking towards the sun. And its magnetic axis is another 60 degree tilted from its rotation axis. And Neptune, it is tilted by 47 degrees. So that means different planets in our solar system have very different characteristics. Now, we know that the sun always emits electromagnetic radiation, which we call as photons. And these photons can be in different wavelengths or frequencies, right from gamma rays to X-ray to ultraviolet to visible to infrared to microwave to radio waves. And it also emits out particles, which we call as solar wind. And these particles are largely protons and a few percent of WNS helium. So it is H plus protons, equal amount of electrons, and then a few percent of WNS helium. Now this wind, which you call a solar wind, which is nothing but a plasma moving out from the sun, but also having the sun's magnetic field, comes and interacts with the Earth, which are a dipolar magnetic field, which you see in the bottom, right? And because the sun also is coming as a charged particles, the solar wind is coming as a charged particles, carrying its own magnetic field, it interacts with the Earth's magnetic field, and the Earth's magnetic field is trying to save itself. It forms a shield around us, and the shield around the Earth creates a magnetosphere. And this phenomena of creation of a field or a cocoon or a cavity around the planet Earth, it safeguards the planet Earth from high energy charged particles coming from the sun. And that is why you create some kind of cavity which is called as a mantosphere. So day side it is compressed because the solar wind is coming with its own pressure, and on the night side it gets elongated. And this process also creates a phenomena which is called aurora, which happens in the polar regions because the field lines are all going and connecting to the earth in the polar regions. And that's why you see aurora formation in the polar regions. Now these auroras can be of different colors. It can be yellow, it can be greenish, it can be reddish, and they are all produced by the excitation of the atoms and molecules present in the Earth's atmosphere at an altitude of somewhere 100 kilometers above the surface of the Earth. So this charged particle which is coming and dumping their energy into auroral region or polar regions produces this aurora because of the excitation of the species or gases present here. And this phenomena is present also on planets like Uranus or Jupiter or Saturn, essentially because they also have magnetic field, which I just mentioned, and they also have a massive atmosphere. But the atmosphere there is not dominated by nitrogen and oxygen as on planet Earth, but that is dominated by hydrogen. So Jupiter is one of the biggest planet, which I just mentioned, but it also has the strongest magnetic field. And that is why aurora on Jupiter is present always. Whenever you look at Jupiter, you will see aurora. And aurora is there not only in the visible, but in ultraviolet, in X-rays, and infrared. So aurora on Jupiter is there in all possible wavelengths you can think of. Okay, and not moving. Now I got it. Okay. So let us look at the inner planet of solar system. I just mentioned, the Jupiter and Saturn, they are dominated by hydrogen. Okay. So if you look at the inner planet, we know that Earth is dominated by nitrogen and oxygen. It is about 80% nitrogen, 20% oxygen, right? But Venus and Mars, that is the planet inner to the Earth and outer to the Earth, they are dominated by carbon dioxide. So nitrogen oxygen is not the dominant gas. It is carbon dioxide, which is almost like 95%. So Mars and Venus are dominated by carbon dioxide, whereas Earth is dominated by nitrogen and oxygen. And here is just a summary which I just mentioning, that Jupiter, Saturn, Uranus, Neptune, they are dominated by hydrogen, H2, and second most abundant gas is helium. Mars, Venus, dominated by CO2. Nitrogen is only few percent. Earth, dominated by nitrogen, and same is the situation for Titan, Pluto, and Triton. Titan and Triton are the satellites of Saturn and Neptune. And then, of course, I will show you some other things. I will skip this. So now I was talking about, the satellites of different planets in the solar system. And Io is one of the Galilean satellites, which is also the most volcanically active body in the solar system. If you look at the surface of the Io, it is called Io or Io or EAO, depending upon how you pronounce it. But the amount of matter coming out from Io due to volcanic activity is about 1 ton per second. It is really very, very large. So if you look at this 4 Galilean satellite, Io is shown over here, along with Ganymede, Callisto, and Europa. Ganymede is the biggest satellite in our solar system. And these are all 4 satellites of Jupiter, which is called as Galileo or Galilean satellites, because Galileo Galilei actually discovered these 4 big satellites of Jupiter. Now, how does they compare with other satellites and even the planets? Ganymede, I told you, is the biggest. Titan, which is the satellite of Saturn, is the second largest. Mercury is smaller than Ganymede and Titan, right? And Io I am showing over here. Moon, our own Earth's moon, is the 5th largest satellite in the solar system. And then comes Pluto, you see over here, right? With this arrow. And Pluto is much smaller than even the smaller satellites, including our own Earth's moon. Now, let me take you to some of the solar system exploration and talk to you about what India has been doing in this area. Chandrayaan 1 is, of course, you must be knowing about that this is one of the very famous mission of India to study the moon, our own moon. And Chandra is what it stands for, right? So Chandra means moon, right? And Chandrayaan means moon's spacecraft, because Yan means spacecraft. And that's how the word Chandrayaan has come. This was a mission which was launched on 22nd of October 2008, about 15 years back, right? And after 16 days of travel, it reached the moon on 8th of November, and it carried 11 experiments on board. And 3 of these experiments are being flown for the first time. So you see this whole spacecraft, which is all loaded with different experiments of payloads, and they're all listed over here. And it was actually truly international in character because there were 10 different countries around the world which was participating in this lunar mission. And you can see it much better over here. And I was directly involved with the experiment called SARA, which also has 2 different sensors sitting on the top deck. You see over here, this is called SINA, this is called SWIM. SWIM stands for Solar Wind Monitor, and SINA stands for Charged Particle Neutral Atom Analyzer. And there's a small box which is sitting on the top, which is called Moon Impact Probe. And this Moon Impact Probe was actually released from the mother spacecraft after we reached the 100-kilometer circular polar orbit around the moon, and it landed onto the south pole of the moon. Let me also talk to you about Mangalyaan, or the MOM, or Mars Orbiter Mission. So India has actually sent the MOM to Mars. Mom, you know, we call, all the children call their mother as mom nowadays, right? So India has sent the MOM to the Mars. And we also call it as Mangalyaan because Mangal means Mars. Yan means again spacecraft. Now this mission was also a very successful mission, which actually was launched on 5th of November 2013. And after 10 months, okay, after 10 months of travel, we reached Mars on 24th of September 2014. And this mission was actually meant to last just for 6 months, but it lasted for more than 8 years. So that means for continuously 8 years, our Mars orbiter mission was around the Mars. And this mission, after it got inserted on 24th of September 2014, that is almost like 9 years back, it made India the first country in the world to have the successful insertion of an orbiter around the Mars in the first attempt. And that is a very, very rare feat. Now this mission was followed by the next mission, Chandrayaan 2, which is the second Indian lunar mission. And this mission has been in orbit. An orbiter is around the moon and working very well. But you know very well what happened to the lander and the rover. We could not land properly, right? And that is why we are now going to have the Chandrayaan 3 mission. And this mission is going to go this year, probably in the next couple of months. And this mission will be the one which will be landing safely and softly on the lunar surface. And then the rover, which is sitting inside this lander, will come out and move on to the lunar surface. And it is going to explore the moon by not just sitting at one place, but the rover coming out and moving across the lunar surface within a kilometer of the landing site. And this is going to be a mission which is very important because we are going to validate all the technologies which we have developed for the landings. So where we are going to land? We are landing into the polar regions. Now, if you look at this map of the moon, and you see where all the landings have happened so far, including the Apollos, the Lunas, the Chang'e mission from China, the Apollo mission from US or NASA, the Luna mission from Russia, they all have landed into the low mid latitudes. Whereas Chandrayaan 3 is going to land into the polar regions. You see here, the orange color. And this is the primary landing site, and this is the secondary landing site or the alternate landing site. So India is going to go and land into a region which has not been explored so far. And this will be the first of its kind of landing onto the moon, because we are going in the polar regions. The next mission which India is undertaking, and this is also likely to go this year, is the Aditya L1 mission. This is the first Indian solar mission. So India is now going to explore not only planets but also the sun. And this mission will go to a point called L1, which is a point between sun and earth. It is about a distance of 1.5 million kilometers. That is 1% of the distance between sun and earth. Okay, so it's very close to the earth and almost like 99% away from the sun. But the advantage with this point is that at this point, the point will go around the sun as the earth is going around the sun. So that means you can get uninterrupted view of the sun continuously. And that's why this point is very important for us to make a continuous observations of the sun. Now this mission is going to measure or look at the sun at different wavelengths. It will be looking at the sun in the visible, ultraviolet, and soft and hard X-rays. And that's why it has instruments called VLC, SOOT, Helios, and SOLAX. But at L1 point, it is also going to measure the solar wind which is coming from the sun. And that's why it has in situ measurements through an instrument called PAPA, ASPEX, and MAG. MAG means magnetic field. So we are going to measure the charged particles which is coming from the sun at different energies. And that's why we have instrument to study the solar wind. And this mission will take about 100 days from Earth after the launch to reach at the L1 point. And then it will go into an orbit around L1 point. L1 point is an imaginary point, right? So it has to go around it. And it moves around as the Earth goes around. And this mission is going to provide us a lot of new information about how the sun is behaving, how the sun processes are happening, what is the cause of the 1 million degree corona on the sun, how the flares are happening, the solar flares we call the CMEs, what we call, that is coronal mass ejections, which you talk about, that affects the planet Earth also. So how the sun and Earth are connected in terms of the charged particles and the radiation coming from the sun will be explored by this mission called Aditya L1. I'm just showing you this last slide, which is just to tell you that now in India, we have an association which is called Indian Planetary Science Association. You can go to this website, which is shown over here, https://ipsa-assos.in. So this is a Indian Planetary Science Association, which was actually launched this year itself in March by the Secretary Department of Space or Chairman ISRO. And this is an association which is actually meant to look at various activities of exploration of the solar system within the country and to disseminate the information about what we have achieved, what we plan to do in the future. And all of you who are interested to join this association can go to this website and you can also register yourself as the member of this association. So with this, I would like to thank you all for listening patiently. And if you have any questions, you can write to me on my email IDs. And here you are also seeing the 4 campuses of PRL, the main campus from where I'm actually talking to you right now. I'm sitting at the top in the multi-story building, which is seeing in this 8th floor building, and I'm sitting in the corner left side topmost place. You are also seeing the Thaltej campus, which is about 5 kilometers from the main campus, and then the Udaipur Solar Observatory in Udaipur and the Mount Abu telescope. So if those who are interested to visit any of these campuses, want to go to visit Thaltej, want to go to Udaipur to visit our solar observatory or Mount Abu observatory, you are all most welcome. So thank you all for listening patiently.